Okay, explanation for assignment 13, take 5. I really hate technology sometimes. Okay, whenever you look at these problems, you have to decide which rule applies. So that means you're really analyzing what the problem is that you're given. So we're going to first look at the bases. When our bases are the same and they're being multiplied, the rule is automatically keep the base, add the exponents. So I kept the 5. 3 halves plus 1 half is 4 halves. Always simplify the exponent. So 4 over 2 is the same as 2. So our problem is really 5 squared, which you know is 25. Number 4, you only have one base and 2 exponents. So you keep the base, you don't really have a choice of what to do with it, and you're going to multiply the exponents. So 2/3 times 1 half. 2 times 1 is 2. 3 times 2 is 6, which simplifies to 1/3. Or when you look at this, notice the 2 on top and the 2 on bottom cancel out, so it just becomes 1 over 3. Okay, one base, one exponent. I know it's a fraction, but it's still only one exponent. Turn it into the radical. Now, in future problems, we just left it at the third root of 6 because 6 was not on our x cubed list. But in this case, we were practicing putting it into the calculator, so we got 1.82. Number 5, we see multiplication again. However, the bases are not the same, so it's not the same problem as number 3. We look at our exponents next. Our exponents are the same. So we get to keep the exponents and do this with the bases. So 3 times 27 is 81. Kept the 1/4. One base, one exponent. Turn it into the fourth root of 81. 81 is on your x to the 4th list, which equals 3. Okay, number 6. We see that we have 9 over 9 to the negative 4/5. So I got the same base being divided. That means keep the base and subtract the exponents. Now, subtracting a negative gets hairy. That's the same as adding. Okay? So what you're going to end up doing is taking 9 to the first power, which is 5 over 5, minus negative 4/5 is plus 4/5. So you get 9 to the 9/5. Easier way to see it is take this negative 4/5 and make it positive by taking this 9 from the bottom and moving it up to the top, and the exponent becomes positive. So now you have two bases that are the same being multiplied. Keep the base, add the exponents. Okay, we've got one base, one exponent, turn it into a radical. Find the 5th root of 9 is 1.55. Bring the 9th power over. 1.55 to the 9th is 51.64. Okay, number 7. 80 to the 1/4 over 5 to the negative 1/4. Bases are not the same, so it's not the same problem as number 6. Okay, I can't keep the base and subtract the exponents. My exponents are similar, but they're not identical, so I can't do 80 divided by 5. So what I have to do is make this positive. So I keep the 80 to the 1/4, bring the 5 on top, and now they do have the same exponent. So I keep the exponent, multiply 8 times 5, and get 400. 400 to the 1/4 is the same as the 4th root of 400. Put that in the calculator, you get 4.47. Number 8, we have two bases that are not the same. Our exponents are the same, but what this would say is to do 7 divided by 4, which is going to give us a weird decimal. So we don't really want to do that. We have the exponent out here, and we have the exponent outside. So remember, when you have two exponents, it means multiply the exponents. So 3 times negative 1/3 is the same as negative 1. So I get 7 to the negative 1 over 4 to the negative 1. Now all I have to do is get rid of those negatives by flipping this base from 7 over 4 to 4 over 7. Okay, number 9. Two bases that are the same being divided. Keep the base, subtract the exponents. 2/5 minus 4/5 is negative 2/5. So I've got one base, one exponent, turn it into a radical. The fifth root of 11 is 1.62. I've got the negative 2, bring it along. Now remember, I don't want it to stay negative, so I have to make it positive by taking the 1.62 and putting it on the bottom of the fraction. Now 1.62 squared is 2.62. Don't leave it as a fraction with a decimal in it, so do 1 divided by 2.62 and get 0.38. Okay, number 10. We see two bases that are different. So we're not keeping a base and adding, but I have two exponents that are the same. So I can take 12 times 8 and get 96 and keep that exponent. I have to bring the 5 over because I haven't done anything with that 5 yet. So now I have one base, two exponents. Multiply the exponents. 3/5 times 5 is 3. And then I just put 96 to the third power in the calculator. Okay, number 11 looks scary because there's a lot going on. Start where most of the stuff is. This is on top. Now we have, you're going to analyze it the same way. I have two bases that are the same being multiplied. That means keep the base, add the exponents. So negative 2/5 plus 2/5 is 0. And remember that anything to the 0 power is 1. So my top has become 1. The bottom, I've just rewritten underneath until I'm ready to deal with it. My top's done, so now we're going to deal with the bottom. I can't keep it negative, so what I'm going to do is flip this base to make it 7, so my exponents are positive. Okay, turn it into a radical. 4th root of 7 is 1.63. Bring over the 3. 1.63 to the third is 4.33. Okay. Number 12 is another one that looks scary, but it's set up similar. So we start on top. We see same base being multiplied. Keep the base. Add the exponents. Bring the bottom over. Now, my bases are not the same. My exponents are not the same. All right, so what I did is I first tried to see if I could make them the same by starting with the common denominator. So I can turn 9 and 4 both into 36. So I took 7/9, multiplied it by 4/4, I got 28 over 36. Took the 3/4, multiplied it by 9 over 9, and I got 27 over 36. So now my exponents are close, but they're not identical. So that means this is actually not helpful to us. So we're going to go back to this. Okay? Now, the only thing I can do with this, because none of my rules apply, is turn it into a radical. So I have the 9th root of 64 to the 7th power, and the 4th root of 4 to the 3rd power. And the only thing I can do is evaluate the top and the bottom separately. So I evaluate this, becomes this, evaluate this, becomes this, and then I just take these and divide them. 25.69 divided by 2.8 gives me 9.18. Okay, number 13. Two bases, not the same. Can't keep it and add. Two exponents, not the same. Can't keep it and multiply the bases. So what I've got is the exponent out here and exponents inside. So I'm going to distribute the negative 3 and multiply it. So negative 3 times 5/9 gives me negative 15 over 9. Negative 3 times 7/9 gives me negative 21 over 9. Just remember, you just multiply straight across. So this is actually negative 3 over 1. Okay, take those exponents and simplify them. They both can be divided by 9, or 3, I mean. So negative 15/9 becomes negative 5/3. Negative 21 over 9 becomes negative 7 over 3. So again, do not have the same exponents. So I can't just go and multiply the 16 and 5 and keep the exponent. So I have to evaluate them separately. Okay? So I have the 3rd root of 16 to the negative 5 times the 3rd root of 5 to the negative 7. So I'm just evaluating that. 3rd root of 16 is 2.52. 3rd root of 5 is 1.71. I have to make my exponents positive. Put 2.52 to the 5th in the calculator and 1.71 to the 7th in the calculator. And then I multiply these. So 1 times 1 is 1. Multiply those bottoms, I get 4,344.68. Now you have to do 1 divided by 4,344.68. And you get this. You might have had it in the calculator where it looked something like this. But it's the same steps. Okay, number 14, our last one. And this one is easy. It's got the same bases being divided. So you keep the base, subtract the exponents. So we get 13 to the negative 2/7. Turn it into a radical. 7 through to 13 is 1.44. Bring over the negative 2. Need to make the negative 2 positive by flipping the base. 1.44 squared is 2.07. We have to divide 1 divided by 2.07 and get 0.48. Okay, so let me know if you still have questions after seeing this explanation, okay?